Today, we're connecting two of the biggest challenges of our time, the fight against cancer and the fight against climate change. Now, on the surface, they seem like totally separate battles, right? But what if they're deeply and surprisingly linked?
So, here's the big question we're digging into. What if our efforts to heal people are in some ways making our planet sicker? We're going to dive into some fascinating research that uncovers this hidden environmental cost of healing and, more importantly, what we can actually do about it. Let's get into it.
All right, so where do you even start with connecting these two massive topics? Well, it really begins by recognizing a fundamental truth. Our planet's health and our own personal health are completely intertwined. You can't separate them.
And this is huge. In 2021, the World Health Organization basically said it out loud. Climate change isn't just an environmental issue. It's the #1 health threat we face. This isn't just about rising seas anymore. It's a direct threat to you and me. And that statement really set the stage for a new way of thinking about diseases like cancer.
And here's the core idea you need to grasp. It's a two-way street. It's not just that a changing climate affects our health. Nope. The very systems we've built to fight cancer, they have a major environmental footprint of their own, and that creates this really complex cycle. Let's break down what that actually looks like. So this cycle is what researchers call a feedback loop, and it's pretty much what it sounds like. One problem feeds into the other, and that makes both of them worse over time. It's a vicious cycle of harm that we really have to understand if we ever hope to break it.
Okay, so step one, the changing climate itself is directly raising our risk of getting cancer. Think about air pollution from burning fossil fuels. That's directly linked to lung cancer. Or think about the carcinogens that get released during these massive climate-fueled wildfires. These aren't abstract threats. They are real-world exposures making people sick. Then you've got step two. As climate change makes extreme weather more common, it literally stops patients from getting the care they desperately need. Studies have shown that when a hurricane or a massive fire hits, clinics have to close, patients get evacuated, treatments get delayed, and all of that can have a devastating effect on a person's chances of survival. So what happens next? Well, with more people getting cancer and facing all these disruptions, the demand for medical services, it just skyrockets. We're talking more diagnostic imaging, more therapies, more procedures, and every single one of those things requires a ton of energy and resources.
And boom, that's what closes the loop. More cancer care leads to a bigger carbon footprint. That larger footprint contributes to the climate change that, you guessed it, worsens cancer risks and disrupts care in the first place. It just keeps feeding itself. So the question is, just how big is this footprint we're talking about?
So let's look at the actual data. To really get a handle on the scale of this problem, we need to understand, how do we even measure emissions? And where are they coming from inside our healthcare system? Okay, a real quick primer here. Emissions are generally broken down into 3 scopes. Scope 1 is the direct stuff a hospital owns, like its furnaces or vehicles. Scope 2 is for the electricity it buys to power everything. And then there's Scope 3. That's the big one. It's basically everything else in the supply chain, from making drugs and equipment to dealing with waste. Now, take a look at this. This chart shows you just how much of an energy hog some of our most critical diagnostic tools are. MRI and CT scanners, which are absolutely essential for diagnosing and monitoring cancer, are incredibly power hungry. They just drink up massive amounts of electricity every year. Let's make that a little more concrete. A single MRI scan, just one, generates about 20 kilograms of CO2 equivalents. Now, that might not sound like a crazy amount on its own, but then you have to remember, there are millions and millions of these scans performed every single year. And here's an analogy that really brings it home. Every time the patient gets an MRI, the carbon cost is basically the same as driving a regular gas-powered car for about 52 miles. That really puts the hidden energy cost of a totally routine medical procedure into perspective, doesn't it? But wait, because here's the biggest shocker of all. While powering all those machines is definitely a factor, it's not even the main source of emissions. Not even close. A staggering 71% of healthcare's entire carbon footprint comes from that massive Scope 3 category, the supply chain. It's the manufacturing of single-use plastics, pharmaceuticals, and all that equipment that does the most damage. Okay, so the problem is clear, it's complex, and it's definitely urgent. But the good news is leaders in this field are already working on a solution. It's called Roadmap 2030. And this isn't some small, isolated idea.
You can see here how this plan, developed by radiologists, actually positions itself right alongside major global efforts you've probably heard of, like the Paris Agreement. By aligning with these huge goals, it's setting a really ambitious target to fundamentally transform cancer care by 2030, making it sustainable for both patients and the planet.
So what does this roadmap actually propose? What's the plan? Well, it's not just one single fix. It's a whole collection of practical, actionable solutions that target every single level of the healthcare system.
The plan is incredibly comprehensive. It's not about one magic bullet. We're talking about educating the next generation of doctors about climate health, making simple changes like just using low-power modes on scanners, and at the same time pursuing high-tech solutions like energy-efficient AI. It's really a holistic approach to changing practices, policies, and even mindsets.
And these are not just abstract ideas on paper. Check out this amazing example from Boston Medical Center. It's called the Clean Power Prescription. They installed solar panels, and now they're using the energy credits they generate to directly lower the utility bills for their low-income patients. How brilliant is that? They're tackling patient debt and carbon emissions in one single move. Now, of course, this kind of transformation isn't going to be easy. There are huge challenges. The constant push for short-term profits can make it really hard to justify investing in green tech, even if it saves money and lives in the long run. And in medicine, look, the patient in front of you always comes first. The real key is to find those no trade-off solutions, things like reducing waste or just scheduling more efficiently, where what's good for the planet is also good for patients and the hospital's bottom line. And this really gets to the heart of it. The authors of this research argue that just like doctors pledge to first do no harm to their patients, they have an ethical duty to do no harm to the planet that sustains all of us. It's a really profound expansion of what a physician's responsibility is. Which leaves us with this final, really powerful question to think about. If a stable climate prevents disease, reduces health risks, and ensures people can get the care they need, then maybe, just maybe, the most important medical intervention of all is ensuring we have a healthy planet to live on in the first place. That's all for this explainer. Thanks for joining us.